Hello, everyone. I'm Richard Harris. I'm with Fulcrum's Knock. I'll give it a minute for more people to join. For this one, we're gonna have a full discussion about data centers and the some of the basic concepts of and essential techno and important technologies for a data center. Uh, shouldn't be anything too deep. Uh, Really, a data center is just a location where usually multiple companies, or it could be just a large data center for just one company that houses their servers. As Cisco defined it as a building block of the internet infrastructure. And pretty much everything you do on the internet goes through is housed by data centers somewhere. And data centers do consume quite a bit of power, so the energy demand that data centers have has been growing, especially in the past few years. Uh, it's- and here's a few statistics and that came up on that. Also, data centers have a few different tier classifications that come down to how reliable a given data center is expected to be. Uh, the the tier classifications were determined by the Uptime Institute. So a lot of data centers are tier one, which means some of them don't have all all of the nice redundancy that you generally would want to have, but also a tier one data center tends to also be cheaper to put your equipment in. They go all the way up to a tier four data center, which a tier four is estimated to have 26 minutes or less downtime per year and has and should have every redundancy that you could hope for in a data center. And, and again, power infrastructure is very important for a data center. So some of the aspects that can make a data center better is having more redundant power systems. So you have their power feeds from the utilities. Ideally, you want it to be from two different substations. You have the UPS systems that the data center has, which are necessary in case power from the utility is interrupted. And also you would have generators. Even with generators, you still are going to need to have UPSs because it can take a brief moment for the generators to kick on. And during that time, if you don't have the UPSs, all your stuff would be down. And then power distribution within the data center is also fairly very important because you can have thousands of amps worth of electrical current going through the data center, and that's going to be far beyond what a lot of people would see at even a normal office building power distribution. Then you have multiple cooling technologies because you have your servers and other IT equipment in a data center, and they all are generating lots and lots of heat. So what's really become kind of the standard cooling method is the hot aisle, cold aisle, because it's very flexible and it's easy to implement. There are some other more advanced options, but some of those are less flexible, so that a colo data center might not do, say, hot containment because then if you're doing hot containment, then the server racks have to be set up specifically for that. And at a colo data center, that allows you to say, bring your own rack. Well, suddenly your rack isn't one built for hot containment. Similarly, there's another technology method called cold containment. And again, a lot of server racks aren't built for cold containment, so it, it's just easier to build for hot aisle, cold aisle, and the majority of server racks will work with that. You have then the AC units for data centers also tend to be a bit different than a normal Freon AC unit because you have ones have them making use of chiller loops and other technologies, as well as unlike say your home's AC unit. The server a data center AC unit needs to constantly be moving air and not slow down the blower motor because you want even if the given server rack may be generating less heat at a given moment, it still needs airflow to be bringing more air by so that it doesn't get you don't have a thermal runaway occur. Also, some data centers, especially with AI coming up, are starting to do liquid cooling. Is like the that new NVIDIA uh, AI rack that they're selling. The unit is 120 kilowatts within one rack, and that's a tall order to cool with just air. And some there's actually a few data centers out there that are doing open air cooling. It's not very common here in Texas, but there are some places that where it is suitable. And yeah, as the notes down here, growing AI demand uh, is increasing the power demand and the cooling demand that data centers have. And here's some info from a case study that Meta did on doing liquid cooling for their AI clusters. I've heard there's some data centers that are starting to look into using small reactors, but I don't think I've heard of any that have actually been completed yet. I mean, it's entirely possible, but usually nuclear reactors have a lot of permitting going on. But yeah, that's that. The only thing I'd heard about that is there's a data center that's being built somewhere in North Texas that is going to be piloting that, and I imagine that they're probably working on getting the requirements ironed out to make it to streamline the process going forward. Also, from what I was looking into, there's a large number of data centers in Northern Virginia. Oh, because I think I must have messed up that slide. Also, a lot of data centers are trying to minimize their environmental impact where they can, because well, it costs them money to consume power. So if they can be more efficient, they can do more. And yeah, a lot of data centers do consume a lot of water for their chiller towers. Another case study is Google's AI cooling. So they had to put in quite a bit of work to cool off their data centers as they're getting into AI as well. Then another thing that's important in a data center or really any network is you have the network architecture. Uh, so some of that comes more into play with data centers that are run by a single company, but larger setups within a colo data center would also have this be applicable. So traditionally, for many years, there's been the three-tier architecture of core, distribution, and access, and that's also the architecture that's used for campus networks. And now a lot of data centers are shifting over to a spine and leaf architecture. And also for a data center, one of the things that's important is security, because without physical security and network security, then well, it wouldn't be very good. Uh, so you have physical security, which can be your perimeter fencing, your physical access controls, having a man trap entrance for the da for actually accessing the data floor, so that someone can't just sneak in too easily. So it helps minimize tailgating. Then of course there's network security. So that, because if someone can get into the network, they might be able to get into the systems that control the physical security, as well as getting in. And if they can penetrate your network security, that also means they could get into your uh, your servers and compromise your data and cause uh, cause issues. They could exfiltrate the data. They could there's lots of things. I don't want to necessarily spend too much time going into every part of it. And of course, there's monitoring and response, because yeah, no security is perfect, so need to be able to monitor to detect any intrusion that wasn't prevented. And when you find that, respond to it and remove the bad actor from from the network. And, one of the things that's important for security is to have a SIM. Uh, yeah. So a SIM will help aggregate your logs and help you actually find trends and what's going on with your network to alert your SOC and respond to it. And one SIM that Fulcrum uses quite a bit is Bully. And, of course, and data centers usually would need a SIM for visibility, compliance, helping monitor for insider threats and operational efficiencies. And SIM can uh, help detect breaches faster and reduce compliance audit costs. Capital One had a incident a few years ago so here's a case study showing how that's related. Also, a lot of servers in general are moving towards virtualization over the past decade or so. So it can make more efficient use of the space that a company is renting in a data center. And that's been evolving from just VMs to containers, Docker, and technologies such as that. And, here's some info from a case study on General Electric, how they consolidated physical servers into multiple VMs. Uh, Also with servers, you have your various storage types. You have direct attached storage, NAS, SAN, and as is becoming popular with the cloud, you have object storage, and you have different tiers of storage for how performant it is, and then you have different storage protocols. NVMe is becoming more prevalent and beyond just the device, the M.2 in your computer. There's also other NVMe implementations of NVMe with NVMe over Fabric and NVMe over TCP/IP. That is the NVMe protocol allows for much greater queue depth and much more efficient use of than some of the older technologies. Hard drives are still around now because they're great for capacity though. And as organizations grow and data and usages of data centers grow, automation is becoming more important. So monitoring the configuration of servers and of network equipment and automating the configuration changes. Uh, so let's see. And, with automation, you can make changes a lot more quickly and consistently, and it can help reduce the human error because if a person has to touch 100 servers, it's likely and they have to do it one by one, it's likely that they'll end up doing something being a little bit inconsistent at some point. But if it's a script that's going to just automatically do the same thing to all 100 servers, you're more likely to have it remain consistent. And, and of course, monitoring of the data center and of all of the systems that you're using at the data center is also important. Is as the power demand in, say, a server rack that's at the data center grows, you need to know when it starts to approach the limit of what the circuit that's providing power to that server rack can handle, and as well as you need to monitor your servers and how much whether something's just not operating efficiently. Is you could end up having some process that's just going haywire, and then that could end up uh, consuming more power. And, and also for larger as the data centers get larger, time synchronization can become important because if the clock on two different systems don't aren't in sync, then the logs that you're looking at to try to troubleshoot an issue might not line up, and it can certainly make it more difficult, as well as with more MFA requirements that are growing in databases, the consistency of time has become more and more important. And there's a few the the technology for time synchronization that servers and data centers in general use to keep time accurate for the longest time has been one called NTP. I'm sure a lot of people are familiar with NTP. And over the internet, it can achieve 10 to 100 millisecond time accuracy. If you have an NTP appliance within your network, so at the data center, you can achieve 1 to 50, you can achieve sub-millisecond accuracy potentially. There's a newer protocol, or relatively newer protocol called PTP, which is capable of sub microsecond accuracy, potentially nanosecond accuracy. Uh, it's a little bit newer. It operates differently, whereas NTP, the client asks what time it is, and the server tells it what time it is. Whereas with PTP, it's able to be set up to where the server will just periodically broadcast the time. So then the server is able. So instead of it having to be a two-way communication, the server is able to. The client is able to basically just listen for that broadcast and immediately know what time it is. So it's able to, and as well as it's capable of accounting for the time delay of the packets going through network switches. If if everything's configured to do so, then so that thus instead of the time being that the server sends out being the same timestamp that the client receives, as it passes through the switches, that timestamp can be updated to account for how long it took for that packet to go through the switch, which is how it's able to achieve down to nanosecond accuracy. They're both still very viable protocols. I'd say PTP is still a little bit new, and some implementations of it are still are not where I would hope them to be. Also, equipment for doing PTP can be a bit more expensive. At least if you want to achieve the peak accuracy. And various industries are using it. Facebook has migrated all of their data centers to use PTP because they wanted all of their databases to be accurate to the nanosecond between each other, so that if a entry was added to a database, so on the other side of the world, it would have a consistent time with with another entry put into a database locally. And then when those two database entries actually convert are brought into the same database, the timestamps would line up. And yeah, then there's a bit more info here about it if you're interested. And here's a case study about NTP with the NASDAQ. So NASDAQ made use of PTP for better accuracy, and it is beneficial for high frequency traders because when they're doing stock trading at that frequency, keeping the time accurate is very important, as you wouldn't want someone buying a stock and then that buy to end up occurring before a sell that someone else was making. Also, for data centers, making sure to plan for disaster recovery and backups are very important. So, yeah, ideally, you want to follow the 3-2-1 rule. You want to make sure that, and you want to be sure of how well your backups are being handled, so you know, so that you can uh, look for improvements. And there's a few standard practices here that are mentioned. And of course, you want to validate your backups on a regular basis. And here's a case study that some people may be familiar with, where of GitLab's DR issue. They had a catastrophic database deletion that turned into a that caused them to completely rework their entire infrastructure. For data centers to mitigate power cost, there's a few things they can do. One uh, one is, for instance, the open air data centers. For instance, if you have a data center in a cold climate, there's some data centers that have foregone having any cooling, any traditional cooling, and they'll just simply circulate outside air. Uh, there's also options for I mean, let's see. Yeah, see, I'm trying to think of a few of the others. And uh, yeah, as well as trying to make another one is making sure that servers are following the hot aisle, cold aisle airflow direction, since that's one thing that some people, especially in a colo scenario, don't necessarily follow because you want to make sure that like for instance, someone will get a network switch and let's say you were to get a Nexus switch, and the switch you purchased is a port side intake switch, but you mount it with the ports facing the hot aisle. Well, now suddenly it's got the airflow backwards to the hot aisle cold aisle direction, and so if it's blowing its hot air into the cold aisle, then that's going to end up causing these potentially servers to draw that heated air in instead of getting the fresh cool air. So that can be a detriment to the efficiency. So making sure that that everything in the rack is actually moving air in the correct direction from the cold aisle to the hot aisle can improve efficiency by all, as well as depending on how the AC return and the and usually the underfloor airflow is set up. You can that can help make it where the hot air will more quickly go to the return and circulate back into the air handler and be cooled back down. Whereas if the hot air gets blown into the cold aisle, it's still going to rise, but it's going to end up taking a longer path to get back to the air handler. There's some efficiency metrics that data centers do look at for efficiency. Uh, you, so you have the power usage effectiveness, which measures the ratio of how much power the data center consumes to how much the IT equipment is consuming. Is you have all of the auxiliary systems of the data center that also have to be powered, like generally the AC systems, the lights, all of that equipment. But the main focus of the data center is your IT equipment because ideally you want that ratio to be as close to one as possible because all of that everything that's not the servers and network equipment is the overhead. So generally you want to try to reduce the overhead as much as possible. And there's a few that have set benchmarks. Google managed to get their ratio down to 1.09 uh, earlier this year. So yeah, and that certainly helps as a metric showing that they've improved their efficiency. The industry average though is 1.56, which makes sense because with a lot of data centers being colo data centers, you can't necessarily ensure that every rack has the correct is going to have the servers oriented or the network equipment and everything oriented to make sure that the airflow is correct, as well as they're not necessarily going to have the blocking plates preventing air from bypassing the server because you want the cold air to only be going into the server, so you want it to be productive in absorbing the heat and carrying the heat away from the server. If you don't have the blanking plates, then you could just have that cold air just passing by the server and not really benefiting anything. which that's where systems like hot containment and cold containment can also improve efficiency. But as I mentioned earlier, hot containment and cold containment are less flexible. Is with one location I worked at previously did have a hot containment system set up, but the server racks there were kind of a little bit unusual in that the back door of them was solid and not mesh, because then at the top of the racks they basically had a chimney connecting up to the AC to so that the AC would be sucking the air directly out of the server rack rather than the server rack just venting it into the room. So in that setup, you have the AC actually pulling the hot air out of the server rack rather than it pulling the just the hot air that's risen to the top of the room. But again, hot containment data center design is less flexible and less of an option with colo data centers because you have to have racks that are specifically designed for hot containment. Yeah, and yeah, and here's a few things I've mentioned ways that can improve efficiency, which yeah, it points out the blanking panels and containment strategies. Uh, and yeah, based on some research, it looks like data centers consumed approximately 460 terawatts globally in 2023. And with the takeoff of AI, I'm sure that's probably going up drastically. And yeah, a case study for that for power efficiency is AWS. Since AWS is the largest cloud provider in the world, so as so it's beneficial to them to improve efficiency, so that because as they make themselves more efficient, they're able to basically make more profit off of it. Because if they're spending less money on the overhead of power, then that's more money that's their profit. Another case study was Netflix. This one should have been over in the backup. Okay, I think some of the slides got in the wrong order. I think this one probably should have been over by the backup slides. Yeah, and there's a number of emerging technologies in data centers. So on the front of water cooling, there's also full immersion cooling where some data centers will have these baths or tubs of some that are basically filled with a non-conductive liquid, and they're able to fully submerge servers into them. That, that can also provide a efficiency gain but it's also it also can add time to maintenance work because if you ever need to take one of those servers out, then there's a lot more involved for doing any maintenance on the server. Quantum computing is coming around, and it's probably going to be more important in the coming years, but it's still, in my opinion, it's still kind of in the research era because it hasn't, but it'll probably become more uh, in the near future. A lot of infrastructure is being optimized for AI these days, and for instance, as I mentioned earlier, the NVIDIA DGX pod that It has that consumes 120 kilowatts per rack, and powering that is obviously a challenge. NVIDIA is looking into reworking the way that that is powered because currently that is being powered with a somewhat normal power connection, but still pretty a little bit exotic. But they're looking into doing 800 volt power. So if they go down that route, they'll have a connection to those racks that'll be 800 volt DC to the rack, and then the servers will basically just connect into a bus bar within the rack for that 800 volt DC power. There's also some data centers are working on a more modular design so that they can stand up more data centers and more quickly. They're also doing data centers in shipping containers. I believe Microsoft and Facebook have experimented with that so they could have rapid deployment of getting a basic data center to a area that they determine needs it for better servicing their customers in that area. Yeah, yeah, battery systems are important for providing UPS backups for data centers, and battery systems are one thing that's definitely changing. There was a data center over in, I believe it was South Korea a few weeks ago that was using a lithium ion UPS setup, and that ended up having a disaster. Yeah, yeah, with immersion cooling, yeah, people have done the mineral oil method for a while, and it's generally fairly interesting. And of course, yeah, the downside is then if you want to upgrade your RAM, you have a lot longer process to clean up the motherboard before you can, put your new RAM in. Also, Microsoft has been experimenting with underwater data centers, so for a few years now. I'm not sure. Some articles I read said that they were possibly abandoning it, but others say that they're still going at it, so not really sure where Microsoft is on that. And there's a lot of certifications that can potentially be important for data centers. Uh, of course, if more of them that a data center were to have, the more customers that will have that favorable opinion of that data center for actually housing their servers. Is, for instance, yeah, like some organizations are bound by various compliance requirements, and if the data center they're putting their equipment in isn't cleared for certain things, then they just simply can't use it. And there's a case study about how Equinox was touting a tier three data center and how it allowed them to demand a premium. And I guess that's as a summary, covered quite a bit of material and some more references. Yeah, I guess any other questions? Looks like we've got about 5 minutes remaining. Or any of the slides that anyone wants to uh, look at more closely. Okay, well, I guess if no one has any questions, I guess I'll go and end it and let y'all head on over to the next discussion that y'all want to check out. And be sure to check out some of the vendors in the expo.
Thank you, Richard. A lot of great information. Appreciate you sharing all of your knowledge with us and great questions from the attendees. So thank you all. Thanks, Richard.
Well, ha have a good day.